In this question, three statements are given. We have to provide the proper reasons for the given statements. The first one is H3PO3 undergoes disproportionation reaction but H3PO4 doesn't. H3PO3 or phosphorus acid undergoes disproportionation because it has both +3 and +5 oxidation states available for phosphorus. In the reaction, H3PO3 is oxidized to H3PO4 and reduced to PH3. H3PO4 or phosphoric acid doesn't undergo disproportionation because phosphorus is already in its highest oxidation state +5 and cannot be further oxidized. Therefore, there are no further oxidation states available for disproportionation reaction. The second one is when chlorine reacts with excess fluorine, ClF3 is produced and not FCl3. This is because the oxidation states fluorine is the most electronegative element and prefers to be in -1 oxidation state. Chlorine can have various oxidation states, but in the case of reacting with fluorine, it tends to produce the compounds where it achieves a +3 oxidation state. Chlorine trifluoride is a stable compound where chlorine is in +3 oxidation state. And another reason we can say ClF3 is more stable compared to FCl3, and the high reactivity of fluorine and strong oxidation nature favors the formation of ClF3 because chlorine can accommodate 3 fluorine atoms in a stable arrangement. The third one is dioxygen is a gas while sulfur is a solid at room temperature. This is due to the differences in their molecular structures and intermolecular forces. Dioxygen consists of diatomic molecules with a simpler linear structure. The only intermolecular forces present are weak London forces or van der Waals interaction. These weak forces are insufficient to hold the oxygen molecules together in a solid form at room temperature, so oxygen remains as a gas. While in case of sulfur, it typically exists as a cyclic S8 molecule and forms a solid with a ring structure. Sulfur molecules are held together by the stronger van der Waals forces due to the larger size and more complex structure of the sulfur molecules. These forces are strong enough to maintain sulfur in a solid state at room temperature. In the second question, we have to draw the structures of the given compounds. The first one is xenon tetrafluoride, which has the square planar geometry because xenon contains 8 electrons. Among the 8 electrons, 4 are used to make 4 covalent bonds with fluorine atoms. So 2 lone pairs will be there in xenon. Due to the lone pair and lone pair bond pair repulsions, the geometry will be square planar. The second molecule is HClO3. Here we could see that chlorine is doubly bonded to one oxygen and singly bonded to another oxygen and singly bonded to one hydroxyl group. This is the structure of HClO3 molecule. Now let's come to the OR question, and the question is, when concentrated sulfuric acid was added to an unknown salt present in a test tube, a brown gas was evolved. This gas intensified when copper turning were added to this test tube. On cooling, the gas A is changed to a colorless solid B. We need to identify the compounds A and B. Here the compound A will be nitrogen dioxide NO2 and B will be the dimerized form N2O4. The second one is to write the structures of these compounds A and B, and the structures can be represented as per the given diagram. In NO2 we could see that one oxygen is singly bonded and the other one is the doubly bonded oxygen, and the dimerized form can be shown as per the given diagram. The third one is, why does the gas A is changing to solid on cooling? Because nitrogen dioxide is dimerizing into N2O4, that's why they are changing to solid form by cooling process. In the B question, we have to arrange the given compounds in decreasing order of their reducing character. The reducing agents are undergoing oxidation, that is the release of electrons. Among these four hydrogen halides, the one which has highest reducing property is hydrogen iodide because iodine is larger in size. And the least reducing character will be for hydrogen fluoride because the size of the halogens increases from fluorine to iodine. In the last question, we have to complete the given reaction. Here we could see xenon tetrafluoride react with SbF5. Then the product is a complex. It contains xenon surrounded by 3 fluorine atoms and antimony surrounded by 6 fluorine atoms. So this will be a complex which is produced by the reaction.